Hello everyone. In this video we'll try to integrate some functions from past paper of grade 12 national examination. For today, the first question, it says which of the following is equal to the integral x over x squared plus 2x plus 1 dx. What we can do, the integral x over x squared plus 2x plus 1 dx, it can be written the integral x over x squared plus 2x plus 1, it can be written as x plus 1 the whole square dx. And then at this point we can say u is equal to, we can apply substitution process, u is equal to x plus 1, then the du will be is equal to dx. But from here we can get the x value. X is equal to, if you shift the 1 to the left side, that is u minus 1. Now the integral is going to be changed completely. In place of x we can write u minus 1 the whole over u square. The denominator is just u. X plus 1 is already substituted by u. Then du. This is equal to the integral. We can give this denominator for each. That means u over u square, it's 1 over u du minus, again separate, 1 over u square, the integral 1 over u square du. And then this is the same as 1 over u, the integral will be ln u minus 1 over u square. Okay, negative of 1 over u square is the derivative of 1 over u. So we can say here plus 1 over u. If you derivate 1 over u, it will give you negative 1 over u square. So plus c, which is ln of, what's u now? Get it back. X plus 1 plus 1 over x plus 1 plus c. This is going to be the integral of the given function. So the answer, it is found in B, but this must be plus. That's it. Let's go to the second question. Okay, the second question again here, it says the integral e the power of 2x minus 4x the whole over x e raised to 2x dx, it says. So we can give the denominator for each of them. So it's going to be e the power of 2x the whole over x e raised to 2x minus, again we can separate the integral at the same time, 4x over x times e the power of 2x dx. There will be dx here also. Then we can cancel this one. So what left? The integral 1 over x left dx minus, in the second one again we can remove the x and the 4 constant, keep it outside. So we do have 1 over e the power of 2x means e the power of negative 2x dx. Then 1 over x dx, the integral of 1 over x, it will be ln x minus 4 times the integral of e the power of negative 2x is just itself, e the power of negative 2x, but times negative 1 over 2. The reason, because the exponent here, the derivative of negative 2x, it's negative 2, but in case of integral we'll take the reciprocal of it. So negative 1 over 2 will be taken. So finally the answer will be ln x will remain as it is, and here negative is going to be plus, and by 2 will be simplified, and 2 times e the power of negative 2x plus some constancy. That's going to be the answer, which is found in the choice A. Yeah. Next question. The next question, which one of the following is equal to the definite integral from 0 to 1 x minus 1 the whole square over x plus 1 dx? What to do here? We cannot apply substitution directly. First we need to square the numerator and divide. So the numerator function, that means x minus 1 the whole square, it is the same as x square minus 2x plus 1. Then divide over x plus 1 means we can divide it. X square minus 2x minus 2x plus 1 can be divided by x plus 1. Okay, let us do this one on another page and we'll come back. So x square minus 2x plus 1, when you try to divide by x plus 1, it will be, x times x will be x square, and x times 1 will be plus x. Then subtract it. X square minus x square will be 0. So when we subtract, x square cancel, and negative 2x minus x will be negative 3x plus 1. Again, division continues because the degree is the same. It will be negative 3 times x will be negative 3x, and negative 3 times 1 will be negative 3. Then subtract, is also cancelled out, and 1 minus negative 4 will be plus, so it will be 4. So we can write the given expression, that means x square minus 2x plus 1 the whole over x plus 1. It can be written as the quotient is x minus 3 plus the remainder 4 over the divisor, which is x plus 1. So the integral of the whole thing means the integral of these things. Separately you can take it. The integral of x minus 3 dx plus the integral of 4 over x plus 1 dx. Okay, let's get back and do it. So now the whole integral from 0 to 1, x minus 1 the whole square over x plus 1 dx. It can be written the integral from 0 to 1, x minus 3 dx plus the integral 4 over x plus 1 from 0 to 1 dx. Now the integral of x minus 3 will be the integral. Separate we can do it. X integral will be 1 over 2x squared minus 3x. The evaluation is from 0 to 1 for each. We can do it better. This evaluation will be from 0 to 1 minus 3x again from 0 to 1 plus the integral of this will be 4 times ln of x plus 1. Again the evaluation is from 0 to 1. Now substitute. When you substitute 1, it will be just 1 square minus 0 square means 1. So 1 over 2 just left. Minus 3 also here left because 1 minus 0. We'll substitute 1 and 0 and then take the difference. So it will be negative 3 plus the same manner 4 times. The next one we will substitute 1 here. It will be ln 2. Ln 2 minus, when you substitute 0 it will be ln 1. Ln 1 means it's 0. So leave it as it is. Take the difference. Crisscross you can use, and 1 minus 6 will be negative 5 over 2. So the answer will be negative 5 over 2. This is equal to negative 5 over 2, the sum of these two, the difference of these two, plus 4 times ln 2 just, because here only ln 2 left. So the answer is found in C. That's it. The next one, it says if f of x is equal to sine x, okay, when x is less than or equal to 0, remember this division point, and the function f of x works 3x square root of x squared plus 1 when x is greater than 0. And then we are asked to find the integral from negative pi over 2 until root 8 f of x dx. This is the same as from negative pi over 2 until 0, the function will be taken as sine x dx. We'll integrate sine x because the function works for x less than or equal to, it is guided by sine x given to you. So from negative pi over 2 until 0, this it contains negative and positive intervals. From the negative pi over 2 until 0, we'll take the sine x plus the remaining from 0 to root 8, the function will be taken the other one, 3x square root of x squared plus 1 dx. Then after this, the value and the integral of sine x will be very easy. It will be negative cos x. Let's write it, negative cos x from what to what? From negative pi over 2 until 0. Plus the other integral, we need to apply substitution. Okay, let's do it in another page. We'll try to integrate now. 3x, the integral x squared plus 1. The square root of x squared plus 1 dx. At this point, we can say this one as u. Substitution. U is equal to x squared plus 1. Then derivate both sides. Du will be 2x dx. But we don't have here 2x, it's 3x. So to make this one 3, what we can do, we can multiply both sides by 3 over 2. This dx. So when you multiply by 3 over 2, this also by 3 over 2, what will happen? The 2 cancelled, and 3 times x will be 3x left. So 3x dx, now it's going to be 3 over 2 du. Okay, now everything is substituted. So we can use the integral 3 over 2 du. We know 3 over 2 is constant, so keep it outside. So 3 over 2, the integral, the other one is root u, radical u du. But radical u means, radical u is the same as u the power of 1 over 2. When you integrate it, you will add 1 on it, so u the power of 3 over 2, the whole over 3 over 2 it will be. So this is going to be 3 over 2, u the power of 3 over 2, the whole over 3 over 2. Now the denominator cancel. What left? U the power of 3 over 2. What's u now? X squared plus 1, the whole the power of 3 over 2. This is integrated already. The whole thing is integrated, and it gives us x squared plus 1, the whole the power of 3 over 2. Okay, so we can write here x squared plus 1, the whole the power of 3 over 2 will be the integral. Therefore, now we'll evaluate each of them one by one. Here the negative keep outside. The negative keep it, and substitute 0 now. Cosine 0, you know, it's 1, and negative pi over 2 substitute. Cosine of negative pi over 2 will be, it will be 0, minus 0 will make it. Plus the other evaluation, substitute, the evaluation is from 0 to radical 8. Substitute radical 8 here. Radical 8 square, it's 8, 8 plus 1, 9. 9 the power of 3 over 2. Plus, again substitute 0. When you substitute 0, 0 square, you know, it is 0 plus 1, just 1. 1 the power of 3 over 2. Again, how to get, this one it's negative 1. How to get 9 the power of 3 over, this also 1. 1 the power of whatever, it's 1, you know. But 9 the power of 3 over 2, how comes? Let's try to show you how it comes. 9 the power of 3 over 2, it can be written, 9 by itself is 3 square, the whole the power of 3 over 2. Then cancel the denominator, 2 and 3 cube left. 3 cube is the same as 27. That's it, the outcome of. So 3 cube will be 27. So when we get back, it's going to be now, which is equal to negative 1 from the first, from this bracket, plus this is going to be 27 plus 1. Actually it's not plus 1 here, it must be minus 1. Yeah, because when you evaluate, first we'll substitute the upper number we substituted, and we have got 9 the power of 3 over 2, then minus substitute the lower point. The lowest point is 0. I mean, when you substitute 0, 0 square 1, I mean 0, 0 plus 1, it's 1, 1 the power of 3 over 2, it's 1. So 27 minus 1 we have to make it. Then when you complete, 27 minus 1, 26, 26 plus negative 1 will be 25. So the answer is found at B. Next question. The next question, which one of the following is antiderivative of f of x is equal to tan x? Antiderivative means the integral of. So the integral of tan x, we are asked dx, which is the same as the integral of tan x by itself is the same as sin x over cos x dx. Then we can substitute as u is equal to cos x, the denominator 1. Mostly better to substitute the denominator function as u when you are using substitution. Then du is equal to cosine derivative will be negative sin x dx. Then multiply both sides by negative, so negative du is the same as sin x dx. Then now the numerator part, it will be substituted by negative du, so the integral will be negative du over u, which is the negative, keep it, ln of u. The integral of 1 over u will be ln u. But what's u? Get it back, negative ln of, the u is cos x, cosine x. But there is negative coefficient here in the choice, it's not written in this form. There is no, here there is negative, there is no negative here. But the negative, you can bring it as an exponent of the value, so ln of it will be cosine of cos x the power of negative 1, you can make it. Cos x the power of negative 1 means 1 over cos x, okay? Cosine x the power of negative 1 is the same as 1 over cos x. And 1 over cos x means sec x, so it will be ln of sec x will be the answer. That's it. These are some integral questions from past papers of grade 12 national exam. I will continue solving integrals and derivative, so don't forget to subscribe and share to your friends. Thank you for watching.